we see the world around us in 3 dimensions. Well, 4 actually if you include time. And you can see quite clearly that this is in the foreground, this is sort of mid-distance, and that, well, that's miles away. So how does it all work? Well, for a start, we can use the size of things to judge how far away they are. So you know that they get smaller as they get further away. And we can also use perspective. The fact that parallel lines, like say the top of this fence and this wire here, don't look parallel to you, but they seem like they're converging to a point. And there's another clue. When you move, objects at different distances from you, like the fence and all the cars and stuff behind, appear to move at different speeds. Things close to you zoom past, whilst things in the distance hardly seem to move at all. Think of, say, cars going along a road. In the distance they seem to move really slowly, but if you're on the curb, they're going really, really fast. This effect is called motion parallax, and in fact it seems like it's the reason why birds like chickens and pigeons bob their heads all the time. They're constantly changing their point of view, creating motion parallax and allowing them to judge distances. Now the thing is, we humans don't have to keep on moving to judge distances, and that's because, unlike pigeons, we have eyes that look forwards. So although we can't see all around us, the fields of view from each of our eyes actually overlap a little, and that gives us an entirely new means of perceiving depth. It's how things like 3D TV and 3D movies work. It's called stereopsis, and it happens because our eyes each see a slightly different view of the same scene. And that means our brains can use the different images and the differences between them to calculate how far away things are. That's why you should be seeing me in 3D now. I'm actually looking at 2 cameras. There's one there and one there. It's a bit like 2 eyes. And you are wearing special glasses which hopefully will allow one of your eyes to see the image from that camera and the other eye to see the image from that camera. Now, the thing is, it's still not as good as reality, because when I'm doing this, then I'm actually focusing my eyes at different depths, and my brain can use the information about that focusing to tell me how far away my hand is. But if I do this to you, then you are actually focusing all the time on the same screen. So you're not getting that extra information, and your brain's probably a little bit confused about where my hand actually is. So it's not perfect yet, but 3D TV does definitely give you that extra dimension.